What if an object from a distant star system adjusted its trajectory to approach Jupiter? Today, we'll be delving into the astonishing revelations regarding the interstellar wanderer, 3I Atlas, recently unveiled by scientists. We'll unpack how this enigmatic entity contradicts known natural laws, explore the potential calculation behind its trajectory, and discuss what NASA's Mars missions captured that leaves us all questioning our understanding. Before we proceed, be sure to hit the subscribe button and give this video a thumbs up. You won't want to miss our next updates. As 3I Atlas speeds through our solar system, scientists have assembled a compilation of phenomena that shouldn't exist. And when I mention phenomena, I'm referring to statistical impossibilities. Let me clarify this because what you're about to learn will forever alter your perspective on this object. First, the Jupiter coincidence. NASA's analyses reveal something truly remarkable. On March 16, 2026, 3E Atlas is forecasted to reach its closest proximity to Jupiter, precisely 53.445 million kilometers away. Now here's where the oddity arises. The boundary of Jupiter's gravitational influence, its Hill radius, is 53.52 million kilometers. These figures are nearly identical, even accounting for margins of error 1 part in 26,000. That's not merely rare. It's suspiciously exact. But wait, there's even more. The object exhibited non-gravitational acceleration near its closest point to the Sun, or perihelion. To put it simply, it altered its path in a manner that gravity alone fails to account for. This course adjustment was precisely the amount necessary to bring it to Jupiter's Hill radius. Without this modification, it would have entirely bypassed that gravitational sweet spot. The L1 and L2 Lagrange points sit directly at this Hill radius. Ideal positions for anything aiming to orbit Jupiter with minimal fuel, almost as if it intends to offload something. Consider this for a moment. An interstellar object traversing for possibly billions of years executes a minor trajectory adjustment at the exact moment to arrive at the perfect distance from Jupiter. What are the chances? The statistical likelihood of this alignment with Jupiter stands at just 0.04. translating to 4 chances in 100,000. And this is merely one anomaly in a growing collection. Now, let's discuss what 3I Atlas exhibited as it passed nearest to the Sun. From July to November, this object demonstrated unprecedented behavior, a sunward jet, an antitail, directed straight towards the Sun. Out of thousands of recognized comets, none have displayed this kind of physical phenomenon. All others create optical illusions due to the angles of observation, but this is distinctly different. This represents actual material propelled toward the Sun. NASA's high-resolution camera on the Mars Reconnaissance Orbiter confirmed this, capturing images which showcased a luminous extension in front of 3I Atlas along its flight direction. Some researchers propose that if this were a technological construct, this beam could act as a protective shield against micrometeorites and rocks impacting at speeds of 60 kilometers per second, releasing 1,000 times more energy than conventional explosives. Let's now delve into the findings from NASA's Mars missions. As 3I Atlas passed within 30 million kilometers of Mars, 3 NASA spacecraft turned their instruments toward it. The Mars Reconnaissance Orbiter captured visible light images on October 2nd, just 0.2 astronomical units away, providing some of the closest visuals ever obtained of this visitor. The images reveal a soft, glowing white sphere, approximately 1,500 kilometers in diameter, including its coma, the surrounding gas and dust cloud. Over a span of 10 days, the MAVEN orbiter collected ultraviolet images from September 27th to October 7th. These UV observations yielded the most detailed chemical composition breakdown of the object ever recorded. And here's where it gets especially intriguing. Even the Perseverance rover, situated on the Martian surface within the Jezero crater, managed to capture faint images of 3I Atlas on October 4th. The exposure times had to be exceptionally long due to the object's dimness as viewed from the surface. However, what these missions discovered in their analyses raises more questions than it answers. The chemical profile of 3I Atlas is unlike anything we've encountered before. The gas plume is enriched with nickel compared to iron, resembling industrially produced nickel alloys. The nickel to cyanide ratio is astronomically higher than seen in thousands of known comets, including the previous interstellar visitor, 2I Borisov. This unusual abundance pattern could suggest something other than natural formation, and the water content is only 4% by mass. Every known comet in our solar system is predominantly composed of water ice, but this one isn't. Some researchers theorize that the plume might be a result of sunlight evaporating ices and dust accumulated on another object during an extended journey through frigid interstellar space, a coating that developed over billions of years on a celestial body moving between the stars. The mass of this visitor is monumental. 3I Atlas weighs approximately 1 million times more than the first interstellar object, Oumuamua, and it's 1,000 times more massive than 2I Borisov, yet it travels at a quicker velocity than both. Herein lies the dilemma. There simply isn't enough rocky material drifting through interstellar space to deliver such a massive object to our inner solar system once every decade. The statistics don't support this finding unless it didn't happen by chance, unless it purposefully headed towards us. The object's trajectory adds complexity to this enigma. It's traveling retrograde against the direction of planetary orbits around the sun. Yet, it aligns within 5 degrees of the ecliptic plane, the path all planets follow. The odds of this alignment are just 0.02. From countless potential approach angles from interstellar space, it selected one that aligns almost perfectly with the planetary disk, resembling a designed path rather than a random one. If you're intrigued by this, please hit the like button, because what I'm about to disclose next will astonish you. The timing of 3I Atlas's arrival was meticulously calibrated. It appeared precisely when it could come within tens of millions of kilometers of Mars, Venus, and Jupiter. And here's the catch. It was entirely unobservable from Earth at perihelion, hidden behind the sun at a critical point in its trajectory. The chance of this timing unfolding is merely 0.00005, 5 chances in 100,000. We remain oblivious to what transpired during those obscured days behind the sun. No observations were possible? Our telescopes were blind? Was it merely passing by? Or did something significant transpire that we completely overlooked? As it neared perihelion, 3I Atlas brightened more rapidly than any documented comet in history. Furthermore, it wasn't just brighter, it was bluer than the sun itself. Some scientists contemplate whether this could signify the activation of some mechanism, possibly an engine. Conventional comets don't exhibit this type of behavior. The jets emanating from 3I Atlas present yet another enigma. They're tightly focused, maintaining their alignment across stretches of up to 1 million kilometers in various directions relative to the sun, despite the object's measured rotation. Natural comet jets tend to scatter, they wobble and disperse. These jets, however, exhibit precision as if directed by something other than random outgassing. To produce the observed non-gravitational acceleration through natural means would necessitate significant evaporation. We are talking about substantial losses of the object's mass. Yet preliminary images post-perihelion indicate that 3I Atlas has upheld its structure, no fragmentation, still a singular entity. So where did this acceleration originate, if not from massive ice sublimation? The surface area required for natural comet activity to sustain the mass ejection of these jets appears unrealistically vast. The calculations don't correlate with what we observe, suggesting the jets perhaps originate from concentrated sources, akin to thrusters. Now, visualize what will happen next. On March 16, 2026, 3I Atlas will reach its closest approach to Jupiter. Should it release any devices, satellites, or technology within Jupiter's Hill sphere, those objects would have to activate engines to slow down. Approaching Jupiter at 65.9 kilometers per second is incredibly fast, so anything discharged would need to negate a significant portion of that velocity. The escape velocity from Jupiter's gravitational pull at that distance is merely 2.2 kilometers per second. Presently, NASA's Juno spacecraft orbits Jupiter. After March 16th, Juno and other missions could observe for any new entities orbiting Jupiter that weren't launched by us. If we discover technological satellites that humanity didn't create, it would demonstrate that Jupiter has caught the interest of another intelligence, another civilization. However, here's a potential disappointment. If 3I Atlas deposits technology at Jupiter but not near Earth, what does that imply? It would mean we are not the focal point Jupiter, the largest planet in our solar system, visible across interstellar distances for billions of years, might indeed be the true target. We, as a species, arrived late to this universal event only a few million years ago, while Jupiter has been broadcasting its presence to the galaxy since the solar system's inception. If something journeyed for billions of years to reach here, then Earth, with the recent emergence of intelligent life, might not even be on the radar as an interesting location yet. Now, let's shift to an even more intriguing point. Recently, scientists have categorized all the anomalies of 3I Atlas based on their statistical likelihood. When probabilities of various independent anomalies occurring simultaneously are combined, the figures escalate dramatically. We're not merely talking about one peculiar occurrence, we're confronted with a series of improbabilities all associated with this object. There's extremely negative polarization, an unprecedented measurement for any known comet, including 2I Borisov. The polarization values are extraordinarily higher than those of normal comets, indicating a potential link to that unusual antitail we mentioned earlier. Natural comets do not polarize light in this manner. Then, something sent a chill down my spine during my first encounter with this data. The direction from which 3I Atlas approached aligns within 9 degrees of the famous WOW signal. You recall that powerful narrowband radio signal recorded in 1977 that lasted just 72 seconds and remains unexplained. The signal was so distinct, so evidently artificial, that the astronomer who discovered it jotted down WOW on the printout. The probability of this directional correlation is a mere 0.0066 chances in 1,000. Could the WOW signal have been a transmission from 3E Atlas's origin area? 48 years ago, something emitted a signal from that region of space, and now an object arrives from almost the same direction, exhibiting behavior that defies natural rationale. Just coincidence? Perhaps. But these coincidences are adding up. If you're still tuned in, smash that subscribe button, as we're about to explore what scientists next seek. The scientific community aims for spectroscopic measurements concerning the jet's speed and composition. This singular test could unveil everything. If the jets originate from ice, sublimating on a rocky surface, the spectroscopy will reveal one particular pattern. If they stem from technological thrusters, a fundamentally different signature will emerge. The chemical compositions, the velocity profiles, the emission spectra all would be distinct. This is the acid test that could yield definitive answers. Since emerging from behind the sun, 3I Atlas has demonstrated new behaviors. It has become markedly brighter, exhibiting fresh ultraviolet and X-ray activity. Its color has intensified, as if entering a new phase of activity, engaging in behaviors it didn't previously exhibit pre-perihelion. Scientists are left pondering a simple question. Why now? What has changed? The images captured by NASA's Mars missions provide crucial data points. The high-resolution camera revealed that the coma, a luminous cloud of material, extends about 1,500 kilometers in diameter. Future image analyses will assist in estimating the size of the nucleus, the solid core at its center. They'll determine the color of particles present in that nucleus, providing insights into its composition and potentially its age. MAVEN's ultraviolet measurements established upper boundaries on the hydrogen to deuterium ratio, a metric that can disclose the origin of an object. Distinct regions of space, different stellar environments leave discernible isotopic fingerprints. Analyzing the deuterium levels allows us to read this object's birth certificate, learning about the conditions under which it came to existence. The fact that even the Perseverance rover could capture images of this interstellar traveler speaks volumes about its brightness. Surface observations from Mars are remarkably challenging for such distant objects, necessitating extremely long exposure times that cause stars to streak across the images while the comet remained faintly visible. But there it was, detectable even from another planet's surface. What stands out to me in this entire scenario is how NASA officials responded during their press conference on November 19th. They presented 3I Atlas as certainly a comet, stressing natural explanations despite the overwhelming cascade of statistical anomalies. When you consider the combined probability of all these anomalies occurring in a single object, the figures dwindle to nearly zero. Each anomaly multiplies with the others: 4 inches, 100,000 times 5 inches, 100,000 times 2 inches, 1,000, and so forth. The product of these probabilities plunges into realms that challenge fundamental assumptions. Scientists are proceeding carefully, as they ought to. Extraordinary claims necessitate extraordinary evidence. Yet the evidence continues to mount, and each new observation contributes another piece to a puzzle that remains unsolved. If we presume this is merely an ordinary comet that accidentally wandered into our solar system, think of what we are actually witnessing. An object from interstellar space, 1,000,000 times more massive than the first interstellar object we detected, arrives with a trajectory that aligns suspiciously well with the planetary plane. It comes at precisely the right moment to pass near 3 planets, while remaining hidden behind the sun at perihelion. It displays non-gravitational acceleration that synchronizes its path with immaculate precision to reach Jupiter's Hill radius. Its jets maintain orientation despite rotation. It contains nickel quantities reminiscent of industrial alloys. It brightens and alters its color in ways typical comets do not, and it came from the same direction as an unexplained radio signal from nearly 5 decades ago. Each singular anomaly in isolation would be noteworthy, yet combined, they create an undeniable pattern. The scientific method compels us to weigh all explanations, even those that challenge our preconceived notions of what's feasible. The forthcoming months will be pivotal. As 3-2 Atlas continues its journey, more observatories will track its path, and additional data will be collected. The spectroscopic measurements sought by scientists could provide clear answers about the jet's origin. Ground-based telescopes will monitor its ongoing fluctuations in brightness and color changes. When March 2026 approaches, all attentions will turn toward Jupiter. If devices are unleashed, if anything remains in orbit around Jupiter that wasn't placed there by us, it would represent an unprecedented discovery in human history. It would indicate that we are not alone. More importantly, it would reveal that another entity is interested in our solar system. They have traversed unfathomable distances to arrive here, potentially over billions of years, to reach this specific location at this precise moment. Yet, even if nothing is released, even if 3i Atlas simply drifts past Jupiter and vanishes back into interstellar space, we are left grappling with questions that will persist. How do we account for the improbable coincidences? How do we rationalize behaviors that diverge from typical comet patterns? How do we reconcile our observations with what we believe we understand regarding interstellar objects? Ensure you're subscribed with notifications activated, as you will want to be among the first to catch updates as this narrative unfolds. The upcoming months could potentially redefine everything we know about our position within the universe. 3i Atlas will come closest to Earth on December 19th, 2025. At almost twice the distance between Earth and the Sun, around 2 astronomical units away, posing absolutely no danger to our planet, yet close enough for detailed observations. Amateur astronomers equipped well may even catch a glimpse of it through their telescopes. Professional observatories will maintain vigilant watch. What follows is uncertain. Will it keep brightening? Will new jets emerge? Will its chemical composition transform as it moves away from the sun? Or will it engage in something entirely unexpected, an event that forces us to rethink everything? The universe is replete with mysteries, but rarely do they unfold on such a predictable timeline, traversing our solar system with such meticulous timing that it almost feels deliberate. Whether 3i Atlas embodies a natural entity with extraordinarily unusual traits, or represents something entirely different, it allows us to expand our perspective on what's feasible. Ponder the implications for just a moment. If this is natural, we must fundamentally revise our models of interstellar objects, comet behaviors, and material compositions derived from other star systems. Our understanding of comet operations, movements, and outgassing would demand a complete rewrite. Textbooks could potentially become obsolete overnight. However, if this is not a natural phenomenon, and even 1% of the anomalies suggest an artificial origin, we are witnessing one of the most significant events in our human history, an arrival from another world, possibly another civilization, creating a path through our solar system with deliberate aim and precision. Instead of merely passing through randomly, it arrives at specific times, targeting precise locations, executing maneuvers that imply intent. The scientific community remains cautious, and rightfully so. Accusations of extraterrestrial technology require steel-proof evidence, rather than mere statistical anomalies and peculiar behavior. However, science also demands we follow the evidence wherever it may lead, even into areas that challenge our established worldview. The primary difference of 3I Atlas compared to previous interstellar visitors is the sheer accumulation of anomalies. Oumuamua showcased unusual acceleration and bizarre tumbling motion, interesting but ultimately inconclusive. 2I Boris looked like an ordinary comet, granting us confidence in our comprehension of what interstellar objects should resemble. Then, 3I Atlas arrived, shattering all expectations. It's almost as if each interstellar guest becomes progressively more extraordinary, driving us away from comfortable explanations. The coming weeks leading to December 19th will be crucial. Observatories globally are coordinating their observations, preparing spectroscopic analyses that may finally provide expansive understanding of those jets. Are they products of ice sublimation, or is there something else at play? The data will reveal everything. Chemical evaluations will disclose details of composition that help narrow down hypotheses. And ground-based telescopes, equipped with contemporary sensors, will capture nuances that previous generations could only dream of. Thank you for watching this far. This is precisely the type of content we will continue to deliver, examining complex scientific revelations and asking essential questions. Don't forget to like this video and subscribe to the channel, ensuring you won't miss updates concerning 3I Atlas and other cosmic enigmas. Following December 19th, 3I Atlas will initiate its lengthy departure from our solar system, heading away from Earth, yet maintaining its trajectory towards that March 16th encounter with Jupiter. The intervening months between December and March will be incredibly intriguing to observe. Will the object persist in its atypical behavior? Will it reveal new jets, colors, or signs of activity? Or will it settle into predictable, comet-like behavior, easing concerns and suggesting natural origins? The possibility of detecting artificial satellites orbiting Jupiter post-March is both exhilarating and intimidating. Exciting because it would finally address the age-old query of our solitude in the cosmos. Chilling because it would indicate an entity capable of traversing interstellar space has taken an interest in our solar system with unknown intentions. Some argue that if 3I Atlas were genuinely artificial, why would it not communicate directly with us? Why the enigma and uncertainty? However, perhaps that's a very human-centric way of perceiving this. An intelligence capable of crossing the galaxy might operate within timelines and priorities unfathomable to us. What we see as significant could be irrelevant to them. Or perhaps the object is autonomous, an envoy dispatched millions or even billions of years prior by a civilization that may no longer exist. These questions plague astronomers, driving them to direct every available telescope toward this enigmatic traveler. Scientific publications concerning 3I Atlas are proliferating at an unprecedented pace. Fresh observations, analyses, and theories are continuously proposed and debated within the academic community, invigorated in a manner rarely seen outside major discoveries like gravitational waves or the Higgs boson. Notably, this object thrusts us into confronting the limitations of our understanding. We have dispatched spacecraft throughout our solar system, landing on comets, examining them closely. We believed we understood these icy visitors. Yet now, something emerges from beyond our solar system, demonstrating that local experiences may not apply to the broader galactic landscape. The universe may be far stranger, much more varied than our limited sampling implies. As we anticipate December 19th and the subsequent Jupiter encounter in March, recognize that you're bearing witness to history. Whether 3I Atlas turns out to be an exotic comet or something beyond that, future generations will reflect on this moment. They'll scrutinize how we reacted to uncertainty, how we collected evidence, how we debated possibilities. They'll remember this as a pivotal juncture when humanity earnestly considered the chance that we might not be alone. Keep watching the skies, keep posing questions, and keep demanding that science follows the evidence without bias toward convenient answers. The truth about 3I Atlas will emerge through meticulous observation and rigorous analysis, not through assumptions or desires. And regardless of what that truth may reveal, it will profoundly expand our comprehension of the cosmos. Thank you for tuning in. If you enjoyed this in-depth exploration of the mysteries surrounding 3E Atlas, ensure your subscriptions include notifications. Share this video with anyone intrigued by space, astronomy, or the potential for life beyond Earth. The coming months are poised to be truly extraordinary, and we will continue to cover every development as it unfolds. Until next time, keep looking up.